Okay, hello everyone and welcome to the BBSim and Scalability Brigade call for December 6th. We have two topics on the agenda for today. The first one is a very quick update on a bug we have been chasing for a little while. In some cases, ONUs were stuck when running the scale test with 16 ONUs and BBSim. This has been closed as a cleanup patch in the logs address the issue, speeding up things, but we expect this issue to come back sometime in the future and we'll need to investigate it a little bit more. As now the test that is validating this periodic volta scale test is failing, still failing, but that's because a different issue that is volta 2237, where there is an errors condition in the OLT application in ONUs, and that is going to be addressed and tracked in this different issue. And then the second topic is a discussion about the Kafka partition strategy document that William was kind enough to put together. So I think that the best way to proceed, if that's okay with you, William, is to move to the document and let you give a brief overview or summary of what is described there. Is that okay?
Yeah, sure.
Do you want to present or do you want me to pull up the document?
Let me just pull it up real quick so I can look at it as I summarize. I think it'll be easier. So let me just pull it up real quick.
Okay.
Yeah, I mean, go ahead and give me right to present. I'll be ready in just a moment.
Oh, but you're connected from the web interface?
Yeah, I am.
I don't.
Yeah.
I don't think I can make you presenter from there.
Oh. Well, then I can't present in that case. I mean, I've presented in the past over the web interface, but if that won't work, then I can't present.
Yeah, I don't see.
I'm pretty sure.
Let's try this. Can you present now?
Yeah, let me see. Yeah, I can present.
Okay, cool.
All right, can you see my screen?
Yep.
All right, great. So I'm just going through the task. The document is up. All right, so as you all know, one way we looked at to scale up the ONU adapter to deal with performance issues, run multiple of them, have them run and have them load balanced across different Kafka partitions. So, I mean, the basic idea, and anyone stop me if they have any questions, but the basic idea is that when you run Kafka, for a given topic, you can allocate a number of partitions, which is a destination on that topic for a message to arrive at. So, using that, consumers of that topic can be assigned a particular partition, and there are different ways to do that, and even multiple partitions. There are different strategies for that, and that's because of the document. But if you put them out across different partitions and then put logic into the producers of the messages to know how to divide the message between partitions, basically you'll have messages sent to different adapters based on the logic that selects a partition. Now, this works really well when you have a stateless a container or stateless app. The ONU adapter is not stateless, so that kind of creates a number of difficulties. And I can't go through the entire document right now. I don't think it makes sense to, but I'm gonna try to summarize some of the main points that I think should be understood. Is that one of the challenges is rebalancing. When you have when the consumers are attached to the different partitions, there are cases where the consumers need to be rebalanced across them. Because, for example, if a partition is added because you want to scale up, now all of a sudden the logic for how you design partitions has to change because there's one more partition. And the automatic ways of doing this, like assigning a partition based on the hash of a key, the math changes if there's a new partition. And the same thing is true if a partition leaves a group, or if a consumer dies. I mean, a consumer dies or joins or leaves. That changes how you do it. Because when you have a consumer, it can let's see. I'm going to say that a partition it doesn't help you give one partition to multiple consumers because you can't divide it any further. So the smallest amount of granularity you can get is one partition per consumer. So if you reach the point where there's one consumer per partition, you have to do something to scale up, which means adding partitions and adding consumers. So this is problematic because when you change how devices are allocated on the partitions, the state that's in the ONU adapter no longer matches whatever the new setup is. So you have to, there's a bunch of different scenarios around that and how you can approach it. And it also depends on whether or not you use consumer groups or manual partitioning. And manual partitioning just you manually assign the partition when you send a message, and it gives you some more freedom over how it. Manual partitioning, you just choose. You manually manage which partition an adapter is assigned to, and you can control some part of how the rebalancing occurs. So one side of it is how do you assign them partitions. The other side is how do you assign messages, how do you assign consumers partitions. So the other side is how do producers assign messages to which partition. And this is tricky in our case because there are two different producers that have to do that for the ONU adapter. There's the core and there's OpenLT. So this is one of the challenges I've summarized in here, but that means there's knowledge required on both sides of where to send it. And that either means a key that is consistent between the two that results in a consistent assignment, or some sort of state is shared. And that the state being shared was one of the main topics on discussion in terms of the comments. There's a few approaches to that. I feel like I'm saying a lot. And does this make sense so far, or should I approach this a little differently?
No, I think this, at least for me, and I guess for whoever read the document, is a good summary. And if I understand correctly, like the main culprit here is to decide whether to use the partition groups or manually assign adapters to the ONUs, and if we decide to manually assign them, how do we assign them? And on the other side, on the producer, how to decide to which partition to send the messages.
Yeah, those are the main issues. And I'm going to scroll down to where I kind of summarize some of those discussion points. The part at the top describes it in more detail, but I can't go through all this right now unless we actually want to do that sort of deep dive. Okay, so I think like I'll just start talking about it. Someone please jump in if you want to say something according to these discussion topics. So how should partitions be assigned to adapter instances? For me, this kind of depends on, to me, it seems like how does Kubernetes handle the scaling up and down of instances? So if you want to do it, how would those mechanisms work? I think there's probably different approaches to this. I think the simplest possible thing to start with would be just doing one partition per consumer, per adapter instance, and seeing how that works. I mean, so, okay. Okay. I'm sorry, I'm not being very structured here. I think if you look at these, part of it is some of these problems are easier to deal with if we fix some issues if we address some things in the ONU adapter. For example, some of the rebalance issues can be addressed if the ONU adapters can reliably be taken down and be expected to pull back up and get their state back and be functioning as you expect if they all died. That allows you to survive various scenarios. For that case, we have to upgrade etcd, the way it stores things in etcd, and just some other aspects.
So maybe one way to approach this, too, would be, like you said, fix the reconcile, right? Because right now reconcile doesn't work even for a single. If reconcile works for a single, and the process could be bounced and come back up and pull its data from etcd and pick up where it left off, would that make all this easier, even up to the point of a rebalance?
Yeah, that would help for rebalancing scenarios where all the devices are reassigned to partitions. If we had a way to know where those were and we could bring them down and have them say, I am on this partition, I now have these devices, let's get going, that would make a lot of it work better.
So, because that will basically make the service stateless, because if it can reconstruct its state, when it comes back up, we can consider that it doesn't have to keep track of any state. So we can just scale it up and down as we want and move it across partition as we want.
I wouldn't say state. So the way it currently starts up, so let's assume, reconcile is fixed, right? And that's kind of number one on the priority list. If when the adapter comes back up, it goes through the process of saying, load up all the etcd data. The way it used to work with 1x, it would jump immediately to in sync. But then even once the adapter says it's in sync, there's local variables that it fills up to not only work from the MIB database, but to work from its own set of objects. So there's a bit of reading from etcd, moving to in-sync, and then filling back up your class object variables that you're working with in terms of the PON port object and the ONU object and a few others. But the point is once it's back up and it's seeded its data back, it shouldn't do anything to the ONU, and it should have pre-filled all of its brains, if you will, by the time it comes back. So again, so stateless, not so much, but recoverable, I think, maybe a better way to say it.
No, I understand it's not stateless, but we can treat it as it was stateless because it can reconstruct its state when it restarts.
Yeah. So if we maybe from this design work from the assumption that the adapter can go down and come back up and continue to operate without having to rediscover anything, that may make this design easier. Or would it? Maybe that's a question.
It would. Yeah. So it would address some of the issues. We just try to write some of this down as we go. So. Let's see. I'm just going. So.
Another thought, just while you're writing is maybe this is kind of a situation where we don't need to be too dynamically clever. Maybe ahead of time, if we know that a particular system is going to support a particular number or a maximum number of ONUs, we ahead of time build it out to say we're going to have 5 partitions and we're going to have 5 ONU adapter instances, and we're going to have them all start up ahead of time and then work from a predefined set of conditions and then to what you expect to be the maximum size. Would that at least initially get us the scale and the stability without having to worry about having to add new partitions or go higher than the old limit?
So yeah, the biggest one of the most typical scenarios is the one where you have to add a partition to Kafka, and that's I discussed that. But Kafka can support quite a lot of partitions without any issue. So you can have hundreds of partitions and only have 5 ONU adapters, and it would work fine. And then in theory, you could scale up the ONU adapters fairly easily. But I think your point goes a little further, is having the ONU adapters up as well. And I think, to me, that seems appropriate since we can predict the scale ahead of time. As long as it can recover, I think it should be okay if you had to, say, bring it down.
When we add a partition, does the identifier of the existing partition change?
When you add a partition, if you're using consumer groups, Kafka will reassign the partitions across the consumer groups so that all the partitions are used.
Okay,
if you're doing it manually, nothing will happen.
Okay, because based on what Matt was saying, that was kind of my thinking too. If we know that one ONU adapter can support 50 ONUs, we can start with a certain number of partitions, and as soon as the device connects, they start filling up the partitions, and we don't really need to have them balanced across partition, at least at the beginning, because we know that one single adapter can support so many ONUs. And then if we need, we add a new partition and a new ONU adapter that is associated with that partition, and that will be filled up, and then we keep on adding. I understand it's not like the most beautiful design, but it sounds simpler than balancing and changing groups. And
the other one thing is that if after 5 though,
ahead of time.
I'm sorry, we're all talking at once. Go ahead.
I was just going to say, all at the same time, knowing the amount of traffic a single ONU adapter can handle, but also, when building out the ODM, the PON network, there are certain hard limits that you already know. I have an X number of PON ports. I can only handle so many ONUs per PON port, and you're building out a particular location where you expect a certain scale, right? It's not like just pure IP traffic where, all of a sudden we just go up from 1 gigabit to 10 gigabit to 100 gigabit. There's a lot of physical aspects that have to happen for ONU counts to go up. And again, part of the planning process could be, all right, in this area, we truly expect to have 500, let's build for 500. Whereas in another, you may expect 2,000, you build for 2,000. And then part of that would be this partitioning.
Yeah, but one thing is, in the case of, say, an adapter not crashing and being reloaded, if you're using consumer groups, rebalancing would happen in that case. So either we would want to say, let's support rebalancing for that case, or we say we assign partitions manually, and we just expect that partition to be recovered again once the ONU adapter is recovered.
Yeah, I'm thinking the latter. Like it's basically bound configuration that says you're starting up and you're bound to this particular partition, and we have 10 partitions and we have 10 ONU adapters, from 0 to 9, and they know where their home is, and that's where they work from.
And also, I think that's fine, because if the ONU adapter goes down, we want to be able to make changes in the network, but connectivity should not be affected.
Right, so we could restart a single ONU adapter, upgrade it, and it would still reconnect back to the partition that it had before. Right, yeah. And again, if reconciliation works like it should, then it should come back up. Its data is all in etcd. It remembers everything. The rest of the system is none the wiser. I guess maybe the bigger point here is maybe trying to be clever about being dynamic ends up forcing us into edge cases that might not really benefit us.
Yeah, I mean, I think given these assumptions, we can avoid dealing with rebalance, which is, I mean, the biggest concern in terms of how this all works, and the thing that requires the most. I mean, the rebalance is what would make manual partitioning kind of annoying. Then you have to go and fix all that back up. But if we don't worry about that, then it's a lot simpler.
Just to clarify, William, when you say rebalancing, you mean that we have two partitions and they are handling 20 devices each. Then we add other two partitions, and so we should have each partition handling 10 devices.
Yeah, that's what I mean.
Yeah, I think that's a very elegant thing to do, but as long as we know that each new device can support the number of devices assigned to a partition, then for now we don't care. Like someone may be lucky and get on a new adapter that is free, and it will be faster than someone else. But I think for now that's fine.
Right. I think the scenario would be like you described. If we had two partitions and two adapter instances, each partition with 20, and then we at some point realize we need a third partition, it's added, but the first two adapters and the first two partitions stay where they've been bound. They don't change their behavior. We just start a third instance of the ONU adapter to work from the third partition.
Yeah, and we have a very lucky guy that has an ONU adapter dedicated to himself for a while, but that's fine.
So that that scenario would work, right? I mean, it's completely static. The first two are none, would not change their behavior.
From my understanding, it would work. How you manage? I mean, the completely static would work. If you want to add a partition and adapter, that should work. How you actually do that in production is a different story, but it would definitely work, and it would avoid worrying about this dynamic.
By the way, William, are you sure about we can dynamically add a new partition? I remember that I couldn't find a solution for that. So at some point, when I start up the system, I configured the system to have like 10 partitions, and with 10 partitions, I can bring up 5 ONUs, let's say. So each ONU adapter can listen to partitions. So Kafka also handles the partition assignment. So let's say you can configure having 100 partitions, and let's say you can have 20 ONU adapters dealing with all of those partitions. So Kafka also handles the partitioning assignment.
Yeah, I mean, that's the consumer group feature.
Oh, okay.
If you put them in a consumer group, it'll handle that for you. But like the consumer groups, they'll each get their own independent assignments that don't affect each other. But in this,
Okay, I see.
So one of the reasons why we asked William to write this document was if Mahir and Sarkant could chime in, because my understanding was their approach was different somehow. Have you guys had a chance to chime into this document or say how similar or dissimilar what William has written is to what you guys were doing, Sarkant?
Yeah. Yes. We were talking long time ago with William. We were discussing. So the both solutions can work. Both solutions have advantages and disadvantages. We need to figure out which one is better.
I'm sorry, I don't understand the both solutions. What is the other solution?
Okay. So the William implemented a manual partitioning schema, while I tried to use the automatic partitioning schema. So basically, when there are multiple ONU adapters, the method I've used, Kafka assigns the partitions to ONUs using a hashing or other algorithm. But William basically override that mechanism. So the assignment of partitions is inside the code in manual partitioning schema. Is that right, William?
Yeah, that's correct. In the document, I summarized kind of my thoughts on the nature of that decision.
So which one is simpler? Which one is more deterministic?
Well, what we just discussed with this making things more static and avoiding rebalancing by doing all ahead of time, that's the manual partitioning route. And that is assuming it sacrifices some of the dynamicness, but it is simpler in the design.
Okay, got it. Simpler to me right now is good for us.
The other point, if we want to move on to the next part, is how is assigning of messages to partitions on the producer side.
Well, I think the easier thing we can do there is to figure out what is the maximum number of ONUs that an adapter can handle, and as they come up, start filling up partitions up to that number.
So Mahir had one time said that he can get 100 ONUs on a single adapter. Is that right? Is my memory right of that?
Yes, it was the situation by that time, but it's always changed. So I don't know with the latest code.
Changed for the better or changed for the worse?
That was for worse.
And what do you think contributed to that?
I don't know. I really don't know. At some point, yeah, we were able to handle 100 ONUs, and at some point we couldn't handle. So I don't know the difference.
And this is all with testing with the new BBSim, right?
Yes.
And this is all with all the 100 ONUs coming up together.
By the way, no. With the new BBSim, we were not able to handle 100 ONUs because there was a feature at the BBSim that we can add delay between ONU discoveries. So at that time, there was no support for that. So the 100 ONUs with the old BBSim.
I see. So they all came up together.
Yeah, when that happens, it cannot be 100 ONUs.
I think that Serkant was saying that they managed to have 100 ONUs with the old BBSim because the delay option was not available yet in the new one.
Yeah.
Oh, so the old one had the delay option.
Yeah.
Yes.
So when you say you can handle 100 ONUs, what kind of delays are you putting in between the ONUs getting discovered?
It was 2 seconds.
2 seconds in batches of what?
Batches of? I couldn't understand.
Well, so like 10 of them coming together, then you wait 2 seconds, then another 10 comes together. Batches of 10, right? Separated by your time delay. Batches of how many?
So the Mahir's implementation was like, so between each ONU discovery, there was 2 seconds delay. And so each ONU was try to start their MIP upload gate. So that implementation was,
so a 2 second delay between each ONU going up to 100 ONUs.
Yes, correct.
Okay, so that's pretty gentle. Okay, good to know.
I think right now we have the same implementation with the new BBSim, but we didn't try, I guess.
Okay, thank you.
So
it's not quite the thundering herd problem that we're trying to solve here, right, Matt?
Yeah, so the thundering herd in the new BBSim, it doesn't have the single-threaded OMCI sender. So the new BBSim with no delay is truly the most brutal tester, which is probably the biggest difference. But with the delay feature, you can simulate what I imagine like what a PON interface would do in terms of managing one plome after the other. But again, I don't think it's going to be 2 seconds. It'll probably be much less than that. So yeah, this the approach coming from this is from a previous conversation where there's dealing with this with Kafka partitioning, but then also dealing with this by having MIB discovery not be so intense. So that's the second aspect that's not covered here that we're trying to do to deal with the thundering herd.
Okay, thank you.
But I think one thing that's important here that's a reminder as a prerequisite to both the MIB template and both to Kafka partitioning is adapter reconciliation. Bouncing that adapter instance and having it recover in a graceful way is number one. That has to be taken care of for both of those to work properly.
Agreed.
Okay, so how do we want to proceed from here? Do we want to try to summarize the proposal to have a very static assignment, assuming that the ONU adapter can reconcile, and then discuss on that and draft an implementation for it?
I think there's one more point we need to address before we summarize it. But I think this one's relatively straightforward based on what we discussed, which is the producer side on the producer side assigning partitions to messages. From the discussion that we had in the document, so the knowledge of which devices and which partition needs to be available to the core and the OpenLT adapter, and which to me made sense was that information should be put into etcd. And they should access that information that way. In theory, so the adapter could put that into etcd, say which partition it's in, and then the core and OpenLT could just use that information.
Right. I was going to say, go even further with the notion of, we know how many ONUs we expect to set up. We know how many ONUs the ONU adapter can handle. Even go so far as like we're doing with tech profile instances. Those are just pre-built in the system as part of the system instantiation time. We ahead of time put in, we're going to have 10 partitions, 10 ONU adapters. We're going to have 5 tech profiles loaded in the system on inception time. And then when the OLT adapter comes up and the core comes up, both those producers will work from that configuration in addition to the ONU on the consumer side.
But that
Would that
that raises the
Yeah, you would just need to know by key which partition. So either by device ID or serial number or something you can rely on.
Yeah.
I mean, you need to build pick it when you have the device object based on some parameter.
I think like it will be much easier that the OLT adapter is the one that decide on which partition this device goes and store it in etcd, and everyone can read it from there. Otherwise, we'll need to inject a huge configuration in etcd for something that we can basically decide on the fly, because as long as we have n ONUs for each partition, we don't really care which ONU is going on which partition.
Yeah, we could probably do it same way by just how the physical layout works. So Resource Manager, has a lot of its storage based on, PON port. So PON port, ONU, there's a hierarchy there that may naturally kind of align with the partitioning we want, because naturally we can't have more than either 128 or 256 ONUs on a PON anyway. And I believe those serial numbers are in that structure and populated by the OLT adapter as it is.
Well, we can also divide
Maybe.
the position by PON, maybe. So you say whatever is.
Yeah, I think it's the same. It would be, the IDing might have to be something synthesized by, PON 0, ONU 0, whatever the Resource Manager identifying structure is. There's some way of uniquely knowing across an entire OLT which ONU instance you're dealing with, and maybe that be the key for hashing the partition or assigning the partition, because it's naturally by the PON it's physically plugged into already anyway.
Yeah, that makes sense to me, especially given we already have that information.
Yeah, and the OLT inherently knows that through the discovery process already. So, so for OLT, I think that works. I bet you an inner adapter. Well, there might be a bit of a chicken and egg there in terms of messaging for something we don't know yet.
Yeah. I mean, the core would have to know when the child device detected occurs. The core would have to know how to fit which partition that child device goes to for the adapter device. So it could be through STD. It could be we just put it in the device object.
It could be part of that, because when that first ONU discovery indication comes in, it goes to the OLT adapter first. OLT adapter then creates the child in the core. So again, the OLT adapter is the entry point for all of it.
So I have two aspects, so two different concepts. First, I don't think we will need all of these having which partition serves which ONU adapter, etc. Because I really believe that we can find a way using a device ID as the hashing key, and we can always find the same partition using that key. So the first problem is rebalancing. When I first tried to understand the concept in the Kafka load balancing, was that Kafka uses a consistent hash algorithm, which means that when there's a rebalancing occurs, the old adapter still can serve the old key, and the new ones, only the new ones, is distributed to the available on adapters. But I tested it yesterday, and it doesn't work like that. So I am trying to figure out what is this consistent hashing algorithm. So I can send some explanations about it. The second concern of mine is I started to work on this in the summer, and by that time there were some discussions about that. Will we still continue to use Kafka, because some of the DT folks was saying that it's too complicated, etc. And maybe we can find a lightweight solution. if we decide to have this load balancing algorithm on Kafka, when we switch to another messaging bus, then probably we will not use the same. And what about the OLT adapter HA or load balancing? Will we use the same mechanism or not? So when I decided to work on this, I wasn't sure this will be the ultimate solution or not.
I think for this, we just assume that we're going to stick with Kafka. Because like you said, if we decide that that's not going to be the inner adapter messaging bus of choice, and now how does OLT do its job? There's a whole other set of questions that come up that throw doubt into all of this. And for now, let's just assume that's what we're using, and we'll go with it.
Okay.
And the hashing, the hash method, it can work for this, and it would be consistent. The problem is you don't know how the devices will be balanced across the partitions. So I shouldn't care about that. Yeah.
So about the rebalancing, I'm going to understand that a bit more. What induces a rebalancing? What decides that there should be a rebalance? Is it just adding a new partition that does that causes a rebalance to happen?
So rebalancing is something that occurs with consumer groups, and there are 4 conditions that result in it. I have them written here. Let me just summarize that. Just a moment. So it happens when a consumer joins the group, when a consumer leaves the group, when a consumer dies, and when a new partition is added.
Okay, so a new consumer being added would be like, again, we've been running with 5 ONUs, and now we decide we want to run with 6, right?
Yes, correct.
Okay.
Scaling up a new ONU.
So again, let's just go back to our, we know the size of our world. Let's say we stick with the design that we know each ONU can handle 50, and we're going to run 10 of them. If that eliminates that rebalance condition. Then the other one would be if it dies and comes back, right? If that happens, why would it just dying and coming back cause it to rebalance?
This is if you use the default consumer group behavior, because it has built with the stateless setup in mind where one will look over. If you don't want to do that, you can either do it manually, or I think there's some ways to modify how consumer groups behave. I didn't look a lot into that, but it is possible.
Because if let's say the assignment to the partition is by device ID, even an adapter bounce won't cause device IDs to change, right? So your partition assignment and your ONU adapter that's handling that partition shouldn't change either, right?
I mean, that wouldn't change, but what would change is Kafka would say, this partition is not covered, let's reassign the partitions so that another consumer covers this partition.
I see. So I guess the question is there a way to configure it to prevent that?
It is possible. I read that you can designate one of them as a leader and can kind of do that. I didn't look into how to do that. The other way is just do it manually, just partition manually, and then you don't worry about that.
Yeah, I believe there should be a way for that, because manual partitioning assignment can be too complicated for me.
I mean, if we're doing manual, the way you should do it is just one partition per adapter instance. Give it the number of them 0 through 100 or 0 through 10, whatever, how many you have, and stick with that. That's what I would say if you were doing it manually. I mean, the consumer groups assuming you can modify a consumer group to not rebalance, then it would just automate that part of the process. So when that could be viable.
Yeah, I think the idea with this would be to avoid the uncertainties of a dynamically built setup, right? If Dynamic helps us, but for an edge case, right? If we decide we want to add multiple or more ONUs, or I guess it's the scenarios that Dynamic solves. Is it really a scenario that we're going to see that often? Is it worth having the whole system be subject to the rules of dynamic complexity when we really don't need that complexity?
Yeah, I think at that point, assuming we figured out how to stop the rebalancing, it's just a matter of which implementation makes more sense in the system. Assuming we remove that dynamicness. I mean, for example, when in mine, I just passed in the partition number as part of the container when I launched it.
So you have a handful of patches that are work in progress patches, but they're not drafts, so anybody can have a look at them to kind of see some of the approach, right?
Yeah.
Yeah, I wasn't aware that drafts are private, so I can't make my drafts public. Oh, by the way, the other problem is when we have multiple new adapters, the core thinks that the adapter is reconciled, so we need to find a solution for that also.
That comes down to fix and reconcile for this case as well.
Yeah, I think so. So my plan is to work on that, the consistent hashing method, and if it can be used with the automatic partitioning, and report it the solution and the problems to you.
I guess it's consistent really means consistent, right? We don't want to have it decide to rebalance things in some scenario that we didn't expect and then nothing worked, right? Again, I'd rather go back to hard-coded known configurations than have some unknown algorithm rearrange the system for us. Because again, we're not dealing with an unknown number of ONUs. We're going to say this OLT will max out at 500. This PON port can only support 128. We have already limits in place that give us a predictable amount of knowledge ahead of time to pre-build what we need, without having to worry about, well, what if we decide to plug in 2,000 more ONUs? Well, even on an existing physical OLT, there are limits in place that prevent that. So, I mean, use that to our advantage in making the system simpler.
Yeah, so you're basically saying we know that an OLT will not support more than 1,000 ONU, so we can pre-provision all the partition we need and call it a day.
Yeah, I think pre-build ahead of time. And you could even go based on the spec and say, a single PON port, I even think the spec won't allow more than 256 ONUs anyway. So, basically build your adapter and your partitioning instances around them.
Yeah,
by the way, for the automatic partitioning to work, there is only needed 10-15 lines of code is needed, because the code already is prepared to use for that method. So the only change is needed to changing the partitioning algorithm in the core, and some of the methods wasn't able to get the device ID, so I modified some of the methods to get the device ID, and everything was ready to work with the automatic partitioning. So it's gonna be a small change, I guess.
Okay, I guess, again, if we could see something running that, again, automatic, stable assignments are consistent. Adapters can bounce and come back. The more standard scenarios, and again, it worked without any rebalancing or any other scenarios that cause the whole system to have to be reevaluated. I mean, we can try it, but again, it's like again the trade-off in cleverness. There's some stability implications there.
But I think the very important thing here is to avoid the rebalancing. How we assign ONUs to partition that is not that much complexity that we are adding or removing, as long as the assignment is consistent.
Yeah, I think so. I think avoiding the rebalancing is key.
Yeah.
And if the automatic method that you're describing does indeed avoid that, then okay, we can have a look at it. But it sounds like this rebalance would be a pretty devastating thing in this particular stateful setup.
Yeah, that's correct.
Yeah, I guess once we are super sure that the reconcile is working in every case, we may go back and revisit these to have a more flexible scenario. But I would say for now, remove all the complexity that we can remove and stick with fixed assignment and fixed partitions.
Okay, so we have, I guess, 5 minutes left, and I was wondering, the point of a design document is to start off by outlining all possible options or maybe different designs, but I think we need to now start driving towards conclusions and a path forward. So on the basis of this discussion today, do you believe you have a set of conclusions that you can put into the design document and then turn those conclusions into Jira stories and work towards it, or is more discussion needed?
I think we have enough to at least draft a proposal.
I summarized some of the main conclusions below, and then some of the points that were contested a little bit. A lot of it, we did come to some conclusions on what makes sense.
Yeah, I think the only question mark left was the Serkan's attempt at using automatic. But again, it's like we really would need to kind of see something in code or proof of concept that really proves that would work. Otherwise, static seems to me the way to go.
Yeah, I mean, if you've drawn that conclusion, then let's just go with that, because it's not like we have a whole lot of time as well. So let's just move forward, right?
Yeah, give me a couple of days if that automatic partitioning solve the rebalancing problem, and then yeah, we can go with the static one.
Okay. I think a couple of days we can do that. But even before any of this starts, we'll have to have reconcile working. So that's something I'm looking at as well. But for this doc, assume reconcile works.
So we have reconcile working for the OLT adapter. That was Abhilash's work, right? And you're saying
correct.
You now need to do the same for the ONU adapter?
So the core part does the job, and OLT adapter has its own resource manager storage that is kind of the analog to MIB storage for the ONU. So for the OLT adapter, it now puts everything in resource manager, pulls everything out of resource manager like it should. For the ONU adapter, the open OMCI library needs to go back to using its external storage class, which means that class needs to be fixed. Once that's done, then it's the question of when the adapter comes back up and it reads from that open OMCI's recovered database, getting the adapter itself started back up to use the data that was stored. So same concept, but just completely different storage mechanism. Storage algorithm, yes, being an open OMCI library versus resource manager.
Okay, got it.
So even without a reconcile, we should be able to start working on this story as in the epi scenario, meaning that like when everything comes up, they should be partitioned correctly across adapters and everything should work. Is that the right assumption?
I think so. For now, if all the adapters start up at system instantiation time and just be sure to not kill any of them, that's a starting point enough to make sure the partitioning works.
Yeah. So we should be able to
the reconcile. Yeah, the reconcile issue can be avoided if assuming everything's good before you start adding devices.
Yeah. Okay. We are at the top of the hour now. I think it was a very good discussion. Thanks, William, for capturing the notes. And let's try to move on with this. And
so one thing, Matteo, was there any discussion on the on Matt's templates, ONU templates?
No.
Or MIB templates?
Not
yet.
In this meeting.
Okay.
No, I'm about halfway through the design. One day next week, if we want to do it during the BBSim call, I can go over it, or if we want to do it one of the Tuesday, Thursday calls, I'm good with either one. I expect I will have it by next week.
Okay. Yeah, maybe even the Tuesday, Thursday ones are fine. Okay.
Yeah. I mean, I was going to say Thursday is probably fine for me.
Yeah, let us know when you're ready. Thanks.
Sure.
Okay. Thank you, everyone. Talk to you soon.
Thank you.
Bye. Thank you. Bye.